These are the notes for lesson 7-6, the common logarithm. You will need a calculator for this lesson. Scientific or graphing, it doesn't matter which. Again, you will need a calculator. Common logarithm is log base 10. It's the common logarithm, one that we use a lot. So, being lazy, we said, hey, I don't want to write the base 10 any more than when you write a square root. Do you put the little 2 up there? No, we use the square root of a lot. We don't put that 2 there, we just leave it as a square root. So, log base 10, we use it enough times that we don't want to write the base 10, so it's just going to be log. Log means the same thing as log base 10. So, if I ask you for the log of 100, you can rewrite this and solve it like we did last chapter, last test. Please do so. So we would pretend that this equals y, and we would ask ourselves, what's the base? Well, it just says log, so the base must be 10. It's not there, but it means it. It's hanging out there invisibly. So 10 to the y equals the argument, which is 100. And 100 is really 10 squared. So y must be 2. So the answer is 2. There is a button on your calculator that just says log. This button is a button we are going to use today. So please take a moment now and find it. Once you have found it, evaluate using your calculator log 6. When you write down your answer, make sure you round to 4 decimal places. You should get that log 6 is about 0.7782. If you can't find the log button, talk to a neighbor. On page 492, there are 2 problems just like that one. Please do both 1A and 1B. Pause the video, get some answers, write them down. Welcome back. For 1A, you should have 0.8451, and for 1B, negative 0.3010. Going on, we are going to use the common log to solve some problems. That looks ugly. So we're going to solve 5 to the x equals 62. Rewriting this problem doesn't help. Log base 5 of 62 equals x. We don't know what to do with that. So instead, we are going to introduce logarithm on both sides. And now you can use your calculator to evaluate those 2 numbers. What is the log of 5? And the log of 62? So you have some decimals. What you're going to do is first use the power property. So we have that x log 5 equals log 62. To solve for x, you should divide by log 5, which is a number you found on your calculator. So x equals log 62 divided by log 5. If you type it in all at once, make sure that you close your parentheses, like so. If you type them in separately, make sure you don't round too soon, because you'll get a very badly rounded answer. And hopefully you get that it's approximately 2.5643. All right, let's try it again. 6 to the x equals 42. So rewriting this again doesn't help us. 6 and 42 really have nothing too much in common. So we are going to take the log of both sides and use the power property to move the x to the front. And just like before, to solve for x, we're going to divide. This time we're dividing by 6. The log base 6's cancel. Again, make sure you close your parentheses or you'll get a bad answer. So take the log of 42 and divide it by the log of 6, and you should get 2.0860. Again, we want 4 decimals just like yesterday. No, we didn't do this yesterday. We want 4 decimals. On page 493, try problem 3A. Pause the video and do it here. Thank you. Welcome back. So for problem 3A, you take the log of both sides. So you have that the log of 3 to the x equals the log of 15. The power property moves the exponent to the front. So x times log 3 equals log 15. To solve for x, we once again divide. So you should have that x is about 2.4650. Sometimes the exponents are a little more interesting, and sometimes we have inequalities. So let's do that one next. 3 to the 7x is greater than 2 to the 5x minus 3. So 3's and 2's have nothing in common. We cannot use exponents to solve this, so we're going to have to use logarithms instead. We take the log of both sides. We move both exponents to the front. So the 7x goes in front of its logarithm. The 5x minus 3 goes in front of its logarithm. So I like to get all the logarithms on one side. So let's divide by log 3 to put it on the other side. So we now have that 7x is greater than 5x minus 3 times a decimal. At this point, we will change this to a decimal. So log 2 divided by log 3 is 0.6309. And now it's just decimals. So this is something you know how to solve. Distribute, get x by itself. Pause and go. Welcome back. On the left-hand side, you still have 7x. On the right-hand side, 3.1546x minus 1.8927. It's a 5, not a 6, sorry. To solve for x, you would subtract. So 3.8455x is greater than a negative number. Divide. And x is greater than negative 0.4922. So let's try that again. Number 6. 4 to the y is less than 5 to the 2y plus 1. So we take the log of both sides. We use the power property. So y times the log of 4 is less than 2y plus 1 times the log of 5. We want to get the logarithms on the same side so that our division problem comes out nicer and our rounding has less of an error. So it doesn't matter which one you divide by, but I'm going to divide by log 4. So y is less than 2y plus 1 times whatever log 5 divided by log 4 is 1.1610. Distribute 2.3220y plus 1.1610. Negative 1.3220. Y is less than 1.1610. When you divide by a negative number, your sign flips over. And I divided that wrong. Let's try again. Negative 1.3220. I get negative 0.8782 as my answer. I hope you did as well. On page 494, problem 4a, please pause the video and do it. Welcome back. So you should have taken the log of both sides and then use the power property to move the exponents to the front. So log of 3 to the 2x is greater than or equal to log of 6 to the x plus 1. Both exponents are moved using the power property. So 2x times log 3 is greater than or equal to x plus 1 times log 6. You could choose to divide by log 3 or by log 6. In both cases, when you do all your work, you should get x is greater than or equal to 4.4190. So I'm going to divide it by log 3. If you divided by log 6 and got that answer, then everything is great. If you didn't, make sure you closed your parentheses. Otherwise, make your work match mine. So divide by log 3 on both sides. And 2x is greater than or equal to x plus 1 times 1.6309. Distribute. Subtract the x over. So 0.3691x is greater than or equal to 1.6309. Divide and you get the answer we were looking for. Oops, I lost a number. 4.4190. Actually, I got 4.4186. So go with that answer instead. All right, there's only one thing left. And it's technically called the change of base. So we want to evaluate log base 5 of 140, which means we don't know what to do. Let's make it equal y. And rewrite it. What's the base? 5. What's the exponent? Y. What does it equal? 140. And then you can take the log of both sides. So you now have y times log 5 equals log 140. And y equals log 140 over log 5. Which you can use in your calculator. Log 140 divided by log 5. Again, close your parentheses or you'll get the wrong answer. It is 3.0704. All right, use that exact same idea. Page 495, number 5. Pause the video and do the problem, please. Welcome back. So when you got down to your final steps, you should have that y equals log 8 over log 6, which is about 1.1606. So how did we do that? We set the problem equal to y, just like we did in problem 7. So it was log base 6 of 8 equals y. We changed it into 6 to the y equals 8. Took the log of both sides. Moved the exponent to the front using the power property. Divide and you get the answer from before. The homework is written down for you, so please do it and have a great day.